All right. So today what we're doing is we are really going to be finding angles from the unit circle, okay? I'm going to give us two little things I'm going to put down on my notes. Finding angles. Well, really an angle, because we're going to find one. Okay? And I'm going to add two more things to your notes. It's going to make it easier, okay? Angles. So first thing, we want to put over here, we know the sine of an angle is the y value. Cosine of an angle is the x value. Tangent of the angle is going to be my y over my x. But on my circle, for me, it's the blue. For me, it's the outside. So I put this on the outside, right? I did that on purpose. All my tangent values, I put on the outside, okay? Just to make it easier, okay? Second thing I'm going to give you to make this easy is we always take the angle closest to 0, okay? Always take the angle close to 0, okay? All right, I'm going to go slowly because I know you can do this, but I'll wait till you're ready, okay? All right, let's see how easy this is. I know you can do this. Sine is the y value. So I need to find a y value of 1/2. So I look at my circle. There's two places. All right? Every point's an x and y. There's two places. We want the angle. We are either going to take a 30-degree angle as the answer or 150. But which one's closest to 0? 30. That is the answer. Thumbs up?
Yes.
Okay. Cosine is the x value. So on an x value, square root of 3 over 2. It is there or there. So it's either going to be 30 degrees or 330 degrees. 30 degrees is closer. Everybody agree with that? That is the answer. Tangent is my y over my x values, but we made it easy. We put all of our tangent values on the outside, right? So I've got one right here at 45, and I got the other at 225. But which one's closest to 0? That is the answer. What do you think? Not too bad. You're actually doing trig that your calculator can do, but you're doing it without a calculator. Okay, sine. We're looking for a y value of 1. Who said that? Yes. Who said 90? Good job, Braden. There's a y value of 1. There's only one answer. There's no other one, so it's easy. It's just 90 degrees, okay? 90 degrees. Cosine of negative 1/2, so looking for an x value. Good, good, good. You guys have beat me to the answer. I like that. Negative 1/2 is here. Total rate 120. It's also down here, but we're not going to take the 240. You guys agree? Too far to go. Too far to run. We're going to take the 120 degrees. Awesome. Now, this is a trick question. It's a trick question. It's undefined because it's the y value. It doesn't, right? Because the farthest, I can go to 1, but if I try to get a height of 2, it's off the circle. So it's just no solution. Okay?
Well, undefined works good.
Undefined is great. Yeah, undefined, no solution. What do you guys want? Yeah. Or even that answer there. That's the empty set, okay? Okay, negative 1/2. So I'm looking for a y value of negative 1/2. Well, it's here and it's here, right? So 210 seems closer, but I'm going to run backwards to it, right? Doesn't running from here to here seem better than going all the way around?
Would it be negative 30?
Negative 30. You okay with negative 30 degrees? From here to here is 30 degrees, right? How about negative 30? Does that make sense? Isn't that faster? I don't want to run all the way around here. I don't want to run all the way there, but the fastest just go boop, negative. You guys see why it's negative 30 degrees?
Yeah.
Okay, boop, negative 30 degrees. And that is the answer. Okay, tangent. Negative square root of 3 over 2. That is the y over the x. But again, I put all my tangents on the outside, right? So one answer is here, and the other answer is here, right? Yes. Yes, negative 3. Isn't that the fastest way to get there? That's the quickest way, is just go backwards. Run backwards on the track. Negative 30 degrees. Okay. Now, normally, if we want to find an angle, we'd go sine inverse of 0.56, right? And we'd get an angle. I'll show you real quick. Okay, if I do that. Okay, so if I went sine inverse of 0.56, I get about a 34 degree angle. Okay, does that make sense? So I get theta equals about 34 degrees. But I want the angle in radians. So what do? Actually, I don't want this answer. I'm not going to take this answer. I want it in radians, so I change my calculator. I change the mode to radian modes. Okay, so then go to my mode button, change it to radians, and I do the whole problem all over again. I go sine inverse of 0.56, and I get an answer. About 0.6. Now that's really hard for kids to understand. That's an angle. I'm going to show you why that's an angle. Okay. It doesn't seem like an angle, does it? So you remember?
Oh, it's a large circle.
Yeah, isn't that nice? Right here is pi, right? Pi's an angle. Pi's an angle, right? 180 pi, 3.14. 3.14 is an angle. So 0.6 is maybe an angle about here. Well, in fact, we know it's 34 degrees going. It's an angle. It's a weird. I mean, if you go to pre-calc, we're going to do a lot. We're going to do everything in radians. For us, I just wanted you to introduce it, okay? But it is an angle. 0.6 is an angle in radians, okay?
It's 34.
So then what about the next one? How do I do this one?
You do the same thing you did there.
But I know my modes. I know my modes already in radians, right? So I'm going to quit that. I'm going to go tangent inverse of negative 0.45, and I get an answer of negative 0.44423, and that is an angle. It doesn't seem like an angle at all, but that is an angle. Okay, last example on this side, cosine of 1.3.
1.423.
So how about this one? Well, if I go
Oh, we do this, man.
cosine
You're right.
It
1.3,
says
what? Domain error. Now, why would that be a domain error?
1.3 is not any.
Well, I mean, if cosine's the x, right? What's the furthest x value you get is 1. 1.3
Oh,
is
yeah,
out
you can't do
here.
the one.
Yeah, 1's it, right?
So this
1.3 is outside.
So no solution?
Yep. And the calculator told me that, didn't it?
Oh,
Yeah.
we're done. That's
It said quick.
And that's it. It's over, but I didn't put a backside to it, so we're done, right? Okay, so now, no solution. No, I took off the back because we don't need it. Because I'm trying to keep it as easy as I can for the end, huh? I took off the hard problems.